forecasting means how much production a farmer or a particular administrative unit will have. So here today we'll discuss how remote sensing, particularly satellite data from various orbit, can be useful for crop inventory and production forecasting. So in general about Indian agriculture, you know why we need. So Indian agriculture, where we require production forecasting, mainly because India is a big country with the more than 65% of population depends on agriculture. If you see net cultivated area, it is around today 45.7% of the total area. From that, food grain production and horticulture production has got received quantum jump. That is because of innovative policy and farm management. At the same time, irrigation input has also increased, which has led to diversified agriculture. Overall, today, agriculture contributes around 70% of total GDP. But important characteristic of agriculture is that it offers large-scale employment. Around 55% of the population that engage in the agriculture sector. But problem with Indian agriculture is that from viewpoint of remote sensing, average field size is very less, 1.15 hectare, compared to Western countries like Europe and USA, where you will get 100-hectare farm. Diversity, another issue is that diversity with respect to the physiography, soil, agriculture climate design, and agriculture cropping system. So if you see in India, we will find different kind of from mountain to almost plain and flood plain and so on. Like climate design from arid to almost per-humid. And soil, we will get loamy sand soil, gravelly soil as a black and alluvial plain. Cropping system, the diverse cropping system is practiced. In Indo-Gangetic plain, you will find mainly rice wheat system, but at the same time in peninsula, you will find rice also in mainly West Bengal and this Tamil Nadu. Then there is in Western India, mainly you find ground wheat based system. Central India, somewhere cotton based system. So different kind of crops are practiced across the India. So all these diversity with respect to physiography, soil types, annual rainfall, and cropping system poses big challenges in front of scientific community as well as planners to have accurate estimate of crop acreage as well as production. Because if there is a large diversity, always it will limit the capability with the remote sensing also. But even though tremendous progress has been made in the agriculture sector, and as of now, 68% of application from remote sensing data realized in agriculture sector. So these are the various sort of application: agriculture land monitoring, crop acreage and production estimate, drought assessment, horticulture crop assessment, cropping system, as well as some applications related to soil, pest disease monitoring, fisheries, and so on. So today we will discuss mainly the crop acreage and production estimate. Why? Because India is one of the few countries that has made it possible to have regular update on agriculture production statistics using satellite input. So satellite based optical data, or whether it is a radar remote sensing data, microwave remote sensing data, both are being used operationally for estimating acreage as well as monitoring crop growth as well as early forecast of the crop performance. So it is not only the satellite data that helps in production estimate. If it is used in combination with certain meteorological variable, then we can have a very good production forecasting system. So this basic is already known to some of you, but even though I can say there why remote sensing evolved. Mainly optical remote sensing, there is an interaction of electromagnetic light or radiation with the surface feature. So whenever this interaction will happen, you will find either reflectors of energy, absorption of energy, and also transmitters of energy. So there is a visible wavelength, red, green, and blue. They are okay because of chlorophyll absorption. Reflectance is very low because this visible wavelength is mainly utilized for the photosynthesis. Then comes to the near infrared range, around 0.7 to 1.10 micrometer. But here, because of very good cell wall interface, if healthy crop is there will be a multiple scattering, and as a result, reflectors will be high if there is a healthy crop. Beyond that, there are three water absorption bands. Mainly, this particular wavelength range, it absorbs short wave infrared wavelength because of presence of water, which is due to liquid water thickness. So I mean to say, whether visible, near infrared, short wave infrared, all these bands have got great utility to develop certain kind of indices which are called vegetation indices or land surface wetness indices. All these indices has got potential to get included in crop acreage estimation as well as improving production forecast. So simple one index, all of you may be knowing. People are talking about NDVI, which is called normalized difference vegetation index. Now this NDVI, if you see any plant, if healthy crop is there, as I said, it absorbs visible wavelength. That means red. So reflectors will be less than 8%. At the same time, it scatter more in NIR region, more than 50%. So if you take ratio like NIR minus R divided by NIR plus R, then it will become like 0.72 or more than 0.7 you will get if there is a pure healthy crop is there. On the contrary, if there is a crop which is a dry, or if there is a crop which is a okay this you can say it is a already ripened, mature, or it is a stress crop, then you will find mainly yellowing of leaves, then green chlorophyll get deteriorated. Because of this deterioration of chlorophyll, the absorption will be less, so reflectors goes up in visible range and near infrared is goes down. As a result, finally you will get NDVI in the order of less than 0.15 or less than 0.1. That is a stress vegetation index. So this vegetation index, which is a basic or it is a one of the best proxy for the monitoring of vegetation cover, vigor, photosynthetic capacity, and biomass. Because of this, mainly in annual crops, initial era of use of remote sensing in agriculture started with use of NDVI index or ratio vegetation index directly to estimate crop yield. So how this okay crop monitoring from viewpoint of okay different satellite sensor resolution. Coarse partial resolution is around 1 kilometer. Then around okay 100 to somewhere 300 meter, and then 10 meter. So depending upon resolution, if area estimation is there, whole continent or whole global, then it may use okay 1 kilometer. But if in India, like okay whole India is there, then you supposed to use somewhere around 100 to 300 meter resolution. And today in India we are having this kind of satellite, mainly OceanSat, OCL, around 300 meter, then advanced with 60 meter. So those kind of satellite may be useful with more 2 or 3 images in a season. You can get better crop area estimation. But beyond that, if you want to have some village level crop area estimation, then you require high partial resolution satellite data like list 4 or this planet scope, or there are satellite like a sentinel. So which are having a resolution around 10 meter and more greater, and also frequent repeated images are also more. So then yield, crop growth monitoring and crop acreage is a mapping. Crop growth monitoring which is a dynamic phenomenon. So for dynamism in the crops during the crop season, to capture, you need to have a more frequent repeat satellite. So those satellites which are maybe having coarser partial resolution little bit, but it should have a more frequent repeat every 10 day or better than that every weekly. Then only you can monitor agriculture crop growth, crop specific condition and crop variable. For yield, those crop growth stages, information acquired at specific crop growth stages, as well as around whole entire profile, all can be made useful for yield estimation. So this is a simple approach how you can go ahead for acreage estimation, crop growth monitoring, then yield estimation. So first crop acreage, it is simple as I said. Every crop has got distinct characteristics: color, shape, architecture, phenology, and time of sowing. So different kind of characteristics are there. So all these characteristics significantly influence the spectral signature. What is this spectral signature? It is nothing but interaction of radiation with the different kind of crop. As a result, different crop exhibit different amount of reflect. Here you can see one example. One image which was acquired, advanced fish image, which was acquired in the mid of February or first week of March. Now, in this is the image spectra generated for the Haryana advanced fish image. So here you can see green, red, near infrared short wave. Particularly in mid of February, you will find wheat crop in the maximum growth stage. As a result, you are finding very highest reflectors because healthy crop scatter more radiation in the near infrared range. Second is a mustard, which is almost in the ripening stage or mature stage. All top leaves are almost dried up, but still there are certain leaves, bottom leaves, still green. Because of that, they are still okay, scattering more radiation in near infrared. Then comes sugarcane. Now sugarcane in the first week of March, it is almost harvested. Only that small stem is left over to grow for in another season, which is called ratoon crop. So this ratoon stem, which doesn't have any kind of reflectance and any kind of scattering in NIR or any kind of absorption in red wavelength. As a result, it is having the least reflectors in NIR and also very highest reflectors in visible wavelength, green and red. So this is a unique characteristic with the multispectral scenario. But if you have hyperspectral data, you can have a more correct picture about the spectral response curve or spectral signature. So what I said, different crop with the varying kind of canopy characteristic affect the spectral signature, and that makes you to distinguish or discriminate different kind of crops with using satellite data. Now crop identification, here we need to understand crop identification and acreage estimation. Crop type identification means crop discrimination. So this kind of thing is more concerned with the distinguishing or classifying all crop types from each other in a region. So you supposed to discriminate or distinguish or classify all crops which are practiced by the farmer in a particular taluka or a district. Then it is a crop identification or crop discrimination. If you are not, because that is a more challenging. You cannot classify every crop with the one satellite. It is like that. One size cannot suit everyone. So if your one satellite image is, you cannot do okay good for justice for all crops. Certain crops surely you will get the good accuracy, but other crops you will not get good accuracy. That is why it is why challenging to have a crop acreage as crop discrimination in a region, but crop acreage estimation is a bit operational or bit possible with the sort of satellite data available in the orbit. So acreage estimation is nothing but concerned with the only few target crops. Here I mean, suppose your interest is to have an acreage estimation of wheat crop in Haryana or Western Uttar Pradesh. So you are all focus or emphasize with respect to the methodology, with respect to the acquisition of correct kind of satellite data, also with respect to the ground truth collection during satellite pass, all you are targeting with respect to the wheat crop. You concern because you will study the phenology of wheat crop when that particular crop is grown, when it reaches to the pre-growth stage. During that only particular time you will acquire satellite data. Then only you will get the best classification or acreage estimation of the wheat crop. Here, other crops, your this accuracy of acreage estimation, you are not worried about the other crops. You are targeting to improve the accuracy and acreage estimation of the only wheat crop. And the other crops you are compromising to certain extent with respect to the accuracy. So, with respect to some approaches also, there are two kind of approaches. One is a boundary overlaying approach. Another is a stratified sample segment approach. Boundary overlaying approach means boundary overlaying approach means that is mainly specific to the small administrative unit. Suppose you want to have a acreage estimation of a taluka or a district, then you can apply this boundary overlaying approach. So moreover, I can say it is more or less like a research purpose methodology. So all pixel or all information, satellite based information of all band within a particular administrative unit, we extract with the boundary of the administrative unit. After extracting like this, okay, you have extracted false color. You will get also, you already had okay this while doing okay the particularly ground truth acquisition of satellite data. During the time of satellite data, you already have collected ground truth. What are the different kind of crops grown in the field on the ground? What is their states? What are the different variety? What is the aerial extent? Those kind of ground truth information already you have collected when there was a satellite pass. So there, after that, you have got the satellite image. You have extracted the satellite boundary. After that, you identify those training sites within the satellite imagery with the computer-based image processing software or algorithm. Then once you identify those training sets, then you apply certain like okay maximum likelihood classifier or unsupervised classifier. Then try to classify all pixel into a different information class. You can see here we could able to do all those pixels based on the spectral signature, kind of okay, tonal variation or kind of okay, spectral composition. We could able to classify them in the different kind of crops like sugarcane, paddy, sunflower, groundnut, and other vegetation coverage. Here actually we are doing crop discrimination, all crop. But if your estimate is only to have acreage estimation, then you can improve even better accuracy. So here also you can see. Now question may arise in your mind that if that boundary overlaying approach is useful only for the district or taluka, then why it is for the used for the Haryana? Now here Haryana is a more or less you can say homogeneous state. If you go during the Rabi season, you will find mainly synthetic group of field. Means where there is a large patches of the wheat crop in Rabi season. So it is mainly dominated by rice wheat system and localized. It is a cropping system or crop practice. These are very specific to the certain district, whether it is mustard or sugarcane or wheat. Now you see this Rewarian, this Batinda, adjoining to this particularly Rajasthan, they are dominated by mustard. But whole central Haryana and this dominated by wheat. Only those are aligned to this Uttarakhand, mainly Pithoragar, Yamunanagar. They are dominated by this particularly sugarcane. So here big patches are there. So it can be possible to even estimate acreage with the satisfactory accuracy for whole Haryana state with a single image like advanced views. So, but if these three images there, even you can do better accuracy like this. Okay, what is the? It is matching with the almost Bureau of Economic Survey estimate, but advanced views, okay, it is a post resolution data, so it has got 22% error is there. But if you have these three images accurately for the particular period of this, then you can get the better, okay, even accuracy with the less than 5% deviation in the acreage estimation at the state level. But as I said, like this, okay, crop inventory. Here you see paddy coarse variety and paddy fine variety. Now question arises in your mind also that now how it can be possible to have okay varietal discrimination with the multispectral data, because you can classify crop in a small unit with the boundary overlaying approach. But here, as I say, it depends on the kind of signature, kind of satellite data, and kind of brown truth you have collected. So particular region specific. Here, particularly in the end of October or mid of October, in Saharanpur, nearby Saharanpur in Uttar Pradesh, there is a one Behad block where two varieties grown which is distinct in their canopy characteristic. So distinct because of their distinction in the canopy characteristic, they are appearing quite distinct in the satellite imagery also. That is why we could able to classify those. One is a light pinkish and one is a dark red. The appearance was there, and we could able to classify because of the completely total different signature of the paddy coarse variety, fine variety. We could able to classify, and that can be you can see here. Difference is there of a paddy coarse variety. This significant difference is there across okay, all three bands. So that is why we could able to classify this. But it is not always possible that you can have a varietal discrimination with the multispectral data. For if you at all you want to attempt varietal discrimination, you have to use hyperspectral satellite data, which has got more narrow band. So any information, distinct characteristic or distinct spectral signature exhibited by the different variety cannot be lost in the hyperspectral image. Okay, this microwave also has got tremendous utility. So there is one next lecture is there mainly on the SWAR application, but I can tell with respect to the crop inventory, multi-temporal data like okay rice, mainly microwave data being utilized operationally for the rice crop inventory because of their distinct crop growth stage, transplanting with the water stagnation background, then volume scattering because of that crop growth, and all those things. That is why it has become more or less operational techniques with the radar set or any microwave remote sensing data, active microwave remote sensing data to have rice crop discrimination, even to certain extent with the variety level because of difference in the phenological stage. So if you have different kind of okay this temporal profile, you can able to discriminate different kind of variety also. So that is okay. Now our next lecture, okay, Dr. Dipandita will discuss more about this. All also maize crop, VVL, different polarization, and all other characteristics, how it will influence the crop inventory. So sample segment approach, okay, for with respect to optical data, there is a if you are interested to have a state level acreage estimation or whole national acreage estimation, then you need to attempt stratification of the total area. The stratification mainly here based on the agroclimatic zones, previous season crop imagery, satellite imagery, or historical crop proportion of the different district in a particular state or country. Based on those historical crop proportion, you can divide whole different district into a classes statum like less than 30% crop area, 30 to 60% crop area, and greater than 60% crop area. Like as a statum. So different kind of procedure is there. Here you try to understand in Punjab. This is the stratification done based on agroclimatic zone. 4, 5, 6. These are agroclimatic zones based on rainfall and temperature. Then, okay, that grid image, gridded file, means fish net, 10-kilometer grid or 5 by 5-kilometer grid is overlaid. Then for particular grid, 10% sample segment, this is a one sample segment, one grid. It is a 5 by 5 kilometer. So only 10% sample segment is selected for the ground truth and satellite data acquisition. So here you can see in a one district only 4 sample segment is falling. So those 4 sample segment satellite image is acquired, then classified as a bit 1, bit 2, bit 3. Now here question arises why we have taken ground truth as a bit 1 for initial classification of sample segment, satellite imagery for sample segment as a bit 1, bit 2, bit 3. Because in India there is a large degree of variation in the time of sowing. In Haryana even you will find crop is grown, some farmer is landlord of the well-to-do farmer grow in the first week of November. Those who are marginal farmer, they get opportunity to sow their crops by first or second week of December. So there may be a variation of 1.5 months. Similarly, across different states also, most of the crops, there is a variation is there in the time of sowing by farmer in the order of 1.5 months. So if there is a time of sowing is different, then it will have a different kind of stage at the time of acquisition of single satellite image. So in the single satellite image, you may not see that okay every stage. Some crop, some field maybe we are finding in the flag leaf stage. Some field you may find in the tillering stage. Even some field you will find in the spike emergence stage. So there will be a possibility that different growth stages with the same crop with the different growth stages in a single satellite image. At the same time, also different crops with the equivalent growth stages. Those both situation, there will be a confusion. As a result, to overcome this confusion, it is always better to have initially identify ground truth as such as growth stage 1, growth stage 2, growth stage 3. Then classify also those using those sites as a bit 1, bit 2, bit 3. Then later on, at the aggregation level, you can merge all these 3 classes into a one. Like here, what is the after that, okay, this merging, then particular district or 4, you can aggregate and multiply with the statum area portion to get the final district level acreage estimation. So this is the what methodology for Punjab. Okay, fish net is overlaid grid, 5 by 5 kilometer grid sample segment, then bit 1, then bit 2, these different kind of stages, crop, growth stage identified. Now it is not required. Earlier, this is an earlier concept. Now you have GP. Okay, you can change the training site and improve the training site collection. After once okay certified, there is a optimum okay transfer separability is there. Then you run the maximum likelihood classification algorithm to classify all sample segment into different information class. Then finally you can get a aggregation of crop acreage at district level. Similar also this same approach. Whatever wheat crop NDVI you have got, all those NDVI itself corresponding to the wheat crop, you aggregate, make area weighted average for the particular district and stored in the historical archive that can be used again in the future for the yield estimation. So that was the approach when you are having the operational approach like crop acreage and production estimation approach. What Space Application Center has. So they have developed this approach to also operationally it can be useful for further developing the model as well as crop acreage monitoring. So that is also okay, wide nationwide if you are wanted to do, then all the same kind of sample segments, stratified sampling segment, but here you require nationwide with the advanced use of wheat data, you require multi-temporal data like wheat and mustard. Now we have tried to understand wheat crop. What is the profile like this? Then mustard crop like this. So here, because mustard crop, if you go to if you have seen, mustard is generally sown end of the October. Then okay, it reaches to the peak growth stage, mainly on tillering stage. So first peak of NDI will attend. Then once it reaches to the flowering stage, because flower doesn't have green chlorophyll, so NDI goes down. So first dip will occur. Again, once okay, those flower turns into a pores, for these green pores adds to the green area index. So further green area index will increase and it will attain another peak. After that, there will be a senescence of leaves because of maturity, leaves dried, and another okay dip will occur. So in case of mustard, there will be a two peak and two dip. So whenever there is a okay flowering stage is there, when okay yellow flowers comes in mustard, it is always appropriate to acquire satellite imagery for the better classification. Single date. For wheat crop, it is always better to have a acquisition of satellite data during the pre-emphasis stage. That means mid of February or first week of March, mainly in the North India. That would be the most optimum time to acquire satellite data, mainly optical satellite data, to have a better accuracy of wheat acreage. So this is what mustard and both are practicing. You are supposed to acquire satellite data at different time. If you are planning to acquire only single satellite image. So under crop acreage and production estimation, so many crops okay covered, mainly major dominated crop, mustard, groundnut, cotton, rice, and wheat. But now, earlier there were only 12 crops are there. Now with the government introduction of the minimum support price, so now government is issuing minimum support price for the 24 crops. To support this scheme, now prototype crop acreage and production estimation project is being undertaken, which is called SUPLA, satellite based food security and waste utilization program for agriculture. So that particular program that deals with the new crops like bajra, maize, ragi, cumin, and so on, cotton. So those were crops. Now acreage and prototype methodology for the yield estimation is under development. So you see overall, I am telling national level with rice and wheat, because rice is the most staple crop followed by this wheat. So rice and wheat, you can do national level classification with advanced WIPS or WIPS kind of satellite data, around 200-meter resolution. State level, you can do with the 60-meter advanced WIPS. If district level is there, you can go for the list 3 kind of imaging, IIRS list 3. If your interest is the mandal level, block level, or village level, you can go for the 6-meter or better space imaging or world view satellite. Conan satellites are also there. These are having a higher resolution in the order of 1 to 2 meter per 1 to 2 meter. So those kind of satellite can also be used to get cadastral level mapping of agricultural land use or agricultural crops. So India has got greater potential with the diverse sort of satellite data which are available from ranging from OCM 360 meter to almost 5.8 meter satellite resolution, which has been operationally being used to get inventory of different crops, whether it is their small patches of horticulture crops or large scale rice and wheat system in the India. So there is a one center which has been institutionalized by Indian Space Research Organization called Mahalanobis National Crop Forecast Center, and this is the center which has been tasked to operationally estimate acreage and production estimation using satellite data, mainly least 3, microwave reset, and sentinel data. So acreage production and estimation for district level. So many crops right now they are issuing operationally for 12 to 13 crops. Other crops are in development of methodology, prototype development methodology is going on with the Space Application Center, IIRS and NRS. There are different centers which are mainly engaged with the agriculture, development of agricultural remote sensing. So there are software also which are mainly useful for forecasting like FasalSoft, mobile application for ground truth, all are being developed. Limitations are there also with respect to crop acreage estimation, mainly small field size. As I said, we don't have okay field size like what US and Europe have. So many satellites which cannot have optimal resolution to support the different kind of crops, because India there are sunflower, small vegetable crops, or they cannot be identified with the existing resolution of the satellite sensor in the orbit. Indian remote sensing satellite. Large diversity of crop. So India is a large country. There are different kind of crops. I have told you more than 130 crops are there. Different crops are practiced by farmer across the landmass, Indian landmass. In a 1 hectare, you will find sometimes in the state like Maharashtra, Gujarat, Madhya Pradesh. In a 1 hectare field, you will find 4 to 5 crops. So it is quite challenging to have a acreage correctly estimation of the acreage. But dominate, major, if there is a major dominating growing districts are there. It has been operationally done and operational bulletins are available. Where but crops is not major, major crop is not majoritarily growing in a particular district, then it is quite difficult to have a acreage estimation of those districts. Then large field to field variability about the sowing culture. As I said, time of sowing. Time of sowing variation greatly affect the accuracy of acreage estimation. Practice of intercropping and mixed crop. Intercropping means growing of 2 or more crops in the row arrangement, like 1 row of bajra and 4 row of groundnut, then 1 row of bajra, 4 row of groundnut. This is called intercropping. So those is a very small patches which cannot mixing that cannot be identifiable with the existing sort of partial resolution. It is not that you cannot do it. You can do it with the UAV. Nowadays, unmanned aerial vehicle with the satellite camera, optical or other kind of satellite hyperspectral camera on board. You can do with the okay even intercropping the delineation or discrimination. But with the existing satellite-based technology, it is not as mature or it is not possible now. Mixed cropping, it is almost impossible task because it is growing of mixing of seeds and throwing on the field. So it cannot be done like because it is like a weeds. Weeds dispersed with the main crop. So mixed cropping is like that. So you cannot discriminate mixed cropping. And these are the bottlenecks where okay we do not have a exactly the estimate of the acreage of different crops in the different district level, because this kind of cropping you cannot delineate with the main crops. High cloud coverage. Cloud data means India is a monsoonal tropical climate. In India, because of this monsoonal tropical climate, there is almost 4 months is a cloud cover from June, July, August, and July, August, September, and October. 4 months. totally it is under cloud. So you won't get the optical satellite data. Surely, okay, our people have, ISRO has developed a reset kind of okay microwave satellite, which is okay already in orbit also, which has got tremendous utility for the acquiring information about crops when there is a cloud. Means this kind of satellites are weather independent. They can acquire information about any crops whenever there is a cloud. But at the same time, there are some issues, sometimes sensor characteristic issues, all those things which inhibit also those kind of satellite data to have acreage of all crops. Because certain like rice and some crops you can do with a certain accuracy, but still it is in the research stage. Then these are the factor: radiometric resolution, partial resolution, number of bands. These are the fact. Already I told number of spectral band. You, if more number of spectral band, you can have a better estimate. You can have a better discrimination of crops type. More good radiometric resolution always improve the accuracy. Partial resolution, depending upon the kind of mapping of acreage of different crops require at different administrative unit level, it influence. Time of acquisition is very much important. Field size, crop proportion, environmental impact, all are significantly influence the crop inventory. Now, second topic, as I said, okay, production forecasting. You cannot miss see differently crop acreage and production estimate, because production estimate always require crop acreage. So we have discussed how we can get better crop acreage from satellite. Now we require crop yield, that means crop productivity per unit area. So once you get crop productivity multiply by crop acreage, you can get production estimate. Now why we need to have a production estimate? We need it for the advanced planning, like crop planning, because majority in, as of now, right now, okay, we are doing crop planning based on the agroclimatic zones, crop diversification, all those things. Now there is a national mission of crop diversification. Government is emphasizing on crop diversification. That is the planning. So advanced, government want that there should be more diversification. There should be a very well developed crop plan is available to have okay fight against the different kind of natural calamities as well as different kind of nutritional and food security. The crop planning, it is not like that you can grow all area under cash crop. You can grow all area under the traditional rice wheat system. Now it is a time we need to ensure good food security as well as nutrition security. So to ensure nutritional and food security of sustainable development goal, we need to have a more advanced crop planning with respect to emphasize more crop diversification, so we can have better security. Then another is the formulation of export and import policies. Why? Because if there is a surplus production, government in generally export. When there is a deficit production, then government need to import. So if this information available well in advance with reasonable accuracy, then government take or policymaker can take certain decision about food procurement. If you all of you know, there was a crisis of pulse crisis. So during those times, depending upon this kind of estimate, government has procured okay pulses mainly two from other countries. But nowadays, okay, pulse production we are self-reliant. Now pulse production has increased also. So some pulses are also exported. So it is like that, okay, like those spices, something we are exporting. Depending upon the how much production you are achieving, how much it is required to meet your low consumption of the country's population, rest is exported. So if advanced estimate is available, we can make this policymaker can make this kind of decision. And the third is the pricing, minimum support price. As I said, for which crop has got this kind of minimum support price. There also acreage and the production estimate is one of the best input, because nowadays crop insurance scheme, all those came on as a weapons or as an indicator of to support farm prices. So minimum support price is also one kind of way to ensure farmers have more money in their pocket. So to have a betterment of the farmers farming community, if this kind of satellite based production estimate available where with the reasonable accuracy, it can support fixing of the main minimum support price. Then transport and storage. There are certain perishable goods like tomato, potato, chilies. Quite often, all of us have seen these tomatoes are thrown on the road, potatoes are thrown in the canals. So these kind of things happen only when there is a surplus production and market price goes down. So whenever those surplus production is there and market price goes down, at that time if you make use of this satellite data to identify the optimum route to have a better access to the market, nearby market. Also to identify the location of the optimal location of the cold storage facilities or food processing unit, then it will have a greater help to the farmers. So production, what would be the production that is required along with the networking, GIS based networking and GPS based networking analysis, that all can makes you enables to identify cold storage facilities as well as food processing unit. Distribution and export and import, that already we have discussed. So crop yield modeling mainly depends on the ability of satellite to supply observation over large area, because different satellites are there. So there are different kind of satellites, observation over area at given times, therefore provides good monitoring technique. There is a strong relationship between satellite derived vegetation indices and crop parameters. So strong relationship, because of this relationship, it can be used to develop a crop yield model. There are different kind of approaches we develop. One is a single date spectral VI based statistical relationship. Another is a spectral crop growth profile approach. Third is the integration of remote sensing and crop growth model. Then there is a deterministic biomass production model. So we will see one by one. There are different kind of approach like single date spectral yield model. Here simply, as I said earlier, normalized different vegetation index, which you can acquire imagery during peak growth stage, maximum vegetating growth stage, and those NDVI you can regress against the historical crop yield available from the this BS estimate or crop cutting data. So that is single date regression model. Then spectral growth profile approach. Growth profile means mainly the profile parameter. Entire season we acquire weekly or 10-day satellite data like advanced sweeps, sentinel. Then study different kind of phenological parameter like peak NDVI, amplitude, start of NDVI, end of season NDVI, length of growing season. All those parameters you can directly relate with the historical crop yield or yield obtained from the crop cutting data. Then third, phenology based, that is same time series data, but mainly phenological matrices only you can relate with the crop cutting experiment data or historical yield data. Biomass production, this is a nowadays most operational model. Many crops like cotton, rice, cotton, wheat, sugarcane implemented on operational basis by Mahalanobis National Crop Forecast Center also. So this mainly based on the solar radiation intersection and crop growth analysis. So as per the approach of the crop classical growth analysis, where amount of dry matter or biomass production in any crops depends on the fraction of solar radiation absorbed, amount of solar radiation absorbed, and its radiation is efficiency. Another is the linking of remote sensing of crop growth model, which is the most advanced approach, where satellite data in the form of satellite derived variable like leaf index or evapotranspiration or soil moisture directly assimilated into the crop growth model. Recently, nowadays, everybody is trying with the now cloud computing, Google Earth Engine. So there is no need to have a storage of the satellite data. Historical geophysical products are available, whether LA, NDA or LST, GPP, all those indices, all products are available. Now with the Google Earth Engine or cloud computing, or you can do okay without acquiring satellite data in your machine. You can develop a directly yield model and forecast what is the yield at the district level or at the pasture level. So this is already I discussed that okay how that stress and unstressed crop behave in the electromagnetic radiation. So one single date model, that is as I said, stratification after stratification, all those sample segment based indices, that derivation of indices will be done, generation of NDVI, then at least this vegetation index which is generated for different sample segment, at least correction, some kind of correction factor has to be employed to correct for the acquisition date, because you require here for single day spectral yield model, NDVI has to be corrected for the maximum vegetative growth stage. So with certain correction factor whether has to be added to get the NDVI value for the maximum vegetative growth stage. After you get the maximum vegetative growth stage based NDVI, you can relate with the yield and finally develop yield model and yield prediction. So here you see this is for Haryana. Different kind of statistical multivariate regressionship are developed. Simply like VI, vegetation index against the yield for different one climatic zone, agroclimatic zone. But here one another variable is added, that is a yield trend. Now why this yield trend is added? Because over the period of time there is a increasing in the advancement of the agriculture technology, like high yielding varieties, more and more increase in the input of fertilizer, input of irrigation. So this technological advancement is increasing. That is why you are getting for any district there is a linearly increasing trend for a crop yield like rice or wheat. So those linear trend you have to take as a additional variable, because and VI is a indicator of proxy of biomass. It is not indicator of the technological trend. So because of to take care of the technological trend, you need to add that yield trend as another variable to have this model to be used for any time. Otherwise, what will happen? Those models you have developed 10 years back cannot be used today, because there is a development of the technology. So those variety models which are developed for those variety may not be suited today, or those because earlier there was a rain-fed cultivation, now it is a irrigated agriculture. So things are changing. So the dynamism with respect to the advancement in technology has to be considered for yield model development also. So here you see we have this scene how this okay advancement or advancement of the satellite based yield modeling, mainly the statistical, can improve the accuracy of yield prediction. So one of the project, student level project, we could able to see that only if it is a only yearly trend. This is econometric model. So only based on the linear trend of the yield with the historical years. How much accuracy? Only you will get the 65% degree of fitness. 65% accuracy or 60% accuracy is there. The moment you involve with the satellite-based remote sensing vegetation index during peak growth stage and yearly trend for the wheat crop, it improved to the 89% or 88%. Beyond that, if you do only vegetation index, only 74%. But once you are combining vegetation index and yearly trend, it is improving further 88. When you combine yearly trend, vegetation index and meteorological factor, it will further improve 93%. So what I want to say, vegetation index is the maximum vegetation index is the best indicator of biomass at the maximum vegetative growth stage, and it is well accepted fact that maximum vegetative growth biomass is directly related to the yield. Second, yearly trend, because of technological advancement, we need to take yearly trend. Third, VI can be a proxy of the biomass at the maximum vegetative growth stage. But if there is some problem later on, there is a stress is there during reproductive stage. So that will drastically affect the partitioning of the reproductive, this photo assimilate to the reproductive structure. So what I want to say, this vegetation index, it doesn't take care of partitioning process. Photo assimilate partitioning is how much that biomass is going towards the yield, seed. So that mainly depends on the meteorological factor, like temperature or photo period. That is why once you include meteorological, it further improves. So one case study we have done with the crop cutting experiment for the wheat crop. Around crop cutting experiment, 3 by 3 pixel, that NDY is extracted. Along with that, we have used also some soil related factor like land productivity index, CIS index, because it is not like that, okay, only vegetation index, satellite based parameter that can improve. You need to have a management of soil. Soil, although it is static, but this particularly crop yield is a culmination or manifestation of the soil management and environmental factor. So if you take, okay, surely, okay, management and this environmental factor, they are exhibited in the satellite data, but soil information is equally important. If you take soil along with that, we can able to improve the further yield. So like this one case study, the crop cutting experiments were there. Then okay, we have done, okay, NDVI at maximum vegetative growth stage. This is Saharanpur crop classification. Then NDVI of wheat crop. Now you see this all students, they are harvesting crops in the Saharanpur area. So these crops are harvested one by one meter, and then okay, yield computed for the different field. Then different models were developed. Only remote sensing based, we see only hardly less than 50% accuracy is there. Once we involve remote sensing along with the land factor, like CIS index or LPI, land productivity index, it little bit improved to more than 50%, 55% or 60%. Again, we improve, we add farmer based, interview based management, how many irrigation applied, how much fertilizer applied. Then okay, we further improve to the 72%. So you can say this is a particular model which is improving up to 72% accuracy for the field scale, this yield estimation. You see, we have been done with the farmer expected yield based on interview as well as independent crop cutting site. So it is giving, okay, almost very good results. Hardly, okay, 10 to 15% error is there in the product yield estimate of the wheat crop with the integration of remote sensing, management condition, and the soil factor. Spectral growth profile approach, which mainly takes care of entire seasonal profile. You see, it is here entire profile. This is our Modi's data, which is coarse resolution satellite data in Western UP. So a profile, bar profile is directly implemented, applied to the entire growing season of the wheat crop. Then we try to estimate peak NDI, start of season NDI, end of season NDI, length of growing duration, and finally it will be useful in the yield estimation. So here, before that, there is another model, as I said, deterministic biomass production model. This is more or less operational, where okay, amount of radiation absorbed and is converted into dry matter directly related to the biomass. So yield equal to summation of photosynthetically active radiation multiplied by fraction of absorbed photosynthetic active radiation. This is the light UV efficiency for different growth stage and harvest index. So by this is a simply multiplicative formula. That is why it is called deterministic biomass production model. And it is one of the most useful approach for quantifying net primary production, useful for the carbon cycle studies. So here you see sugarcane, these three, okay, the crop inventory, then finally with the time series analysis, you can identify start of season, end of season, peak NDVI by applying time set series, time set with a different kind of algorithm. You derive start of season, end of season, peak NDVI, NDVI amplitude, and so on. All these can be related with the yield obtained from the crop cutting estimate. You will finally get the yield model. Like this, okay, in sugar cane, you see ratoon cane and planted cane. We could able to develop certain kind of yield model with the accuracy around, okay, 75%. But this is okay done for the every field scale, so we can get the yield for the every field, and then finally it was integrated for different villages. What is the village level total production estimate? Because area we have got from GPS survey, and then also we have got yield, and finally village level production estimate. So there are certain kind of approaches are there with the high resolution satellite data, along with the that can be employable to get the village level crop production statistic, particularly if you have good ground truth or GPS based field level survey data is available, then you can make able to do field scale crop yield estimation. But coarse resolution data are also useful for the phenology based yield model development, like the same for cotton crop. We could able to see peak NDVI and amplitude, same like cotton, sugarcane. Sugarcane also peak NDVI and amplitude is related directly with the crop yield. Same another cash crop, cotton in the Maharashtra region, also peak NDVI and amplitude is related with the yield, and it can be useful for further developing yield model. Then biomass production model, already I told this is a physiological crop growth based analysis. Here mainly actually if you have satellite data like advanced weeks, MODIs or these days Sentinel data. Sentinel every weekly data is available, 10-meter resolution. You can get the NDVI data set, do certain kind of ground truth to get the FPAR measurement and develop FPAR NDVI equation like this. Then you get the FPAR images. Okay, if you don't have photosynthetically active radiation, you can still okay use certain meteorological station observation, get PR estimation, photosynthetic active radiation estimation, and use interpolation some techniques and prepare PAR map, photosynthetic active radiation maps, literature based harvest index, and some constant you can use to finally get the yield estimate. Like this year, okay, for Haryana, wheat area we can got from the advanced weeks or anything, NDVI for particular 8-day image, PAR. PAR is estimated for particular 8-day period. Then this PAR is multiplied with the NDVI based formulation. Simple relationship get with the FR to get FR. FR is the multiplied with PAR, you will get APAR. Then biomass, APAR for different crop growth stage. Multiply with light efficiency, finally you will get biomass. And biomass converted into yield by multiplying with the harvest index in the order of 0.35. So here you see harvest crop yield. Now you see crop yield Western UP and Haryana. Western UP within 10% of the official estimate. It can be estimated with this kind of biomass semi physical model. And in Haryana also within 10%, but only those plain districts. The moment you are coming in the hilly region, because of some error occurred due to interpolation without taking into lapse rate, temperature based stress scalar cannot be correctly interpolated. So if you are estimating temperature based part, photosynthetic active radiation, then it will goes wrong, particularly in the hilly district. But rest plain district it is working well. But in Haryana, this okay, Maharashtra, same model like the efficiency model, it is working nicely. But okay, yield estimation is in the error of 25 to 40% error is there. But different kind of models are there. So base model is here you are finding, okay, here it is seen LU based model, crop simulation model, this spectral model and phenology based model. So phenology based model is giving the best accuracy for the yield estimation compared to even the semi-empirical physically based light efficiency model. So lastly, okay, integration of remote sensing. Because all this model what we have discussed today, that is largely amenable to the satellite observation or easily amenable with the satellite observation. But there are certain advanced simulation models which are simply the program or you can say software, inbuilt program or software which can simulate behavior of plants as a function of environment or weather management and soil condition. So this kind of model we simulate daily dry matter production, leaf area index, photo assimilate partitioning, rate of development, water balance component, and finally yield. So they are mainly the, you can say, continuous. They generate continuous description of plant growth over the period of interest. But on the contrary, remote sensing observation are discrete because multispectral observation like okay, leaf 3 available every 23 days. Landscape also almost same repeativity 23, 24 days, 22 days. So those observation 22 days, it is not providing remote sensing, is providing complete distribution of the entire season or growth behavior of entire season. So we need to integrate those discrete observation with the continuous observation simulated by the simulation model. So it would be difficult to conduct studies on integrating remote sensing with the crop growth model. There are different approaches being implemented to integrate remote sensing with the crop growth model. One is the direct comparison of model prediction and remotely sensed estimate. These are all advanced approach. Here you can compare directly LAI and evapotranspiration estimate with the LAI and evapotranspiration estimate from the remote sensing. Another iterative adjustment of crop genotypic parameter because all crop simulation model require phenotypic and genotypic parameter as well as initial condition like soil moisture, sowing time. So those initial conditions you can keep on varying. Then iteratively you adjust the base genetic parameter and initial condition so you can get better matching between the remotely sensed estimate of LAI and evapotranspiration with the crop model simulation. Third is the coursing. Coursing is a different thing where okay, if you are having the source code of a particular simulation model, then that source code, most of the models simulate biomass and LAI based on the growing degree days. Because growing degree days is an indicator of plant development only. Instead of growing degree days, we are asking those models by changing the source code that instead of growing degree days model, whenever there is satellite based observation are available, you take that. So we are putting directly those relationships between the LA and NDVI within the model source code. Fourth is a radiant transfer model because canopy radiant transfer model they simulate reflectance and also we get reflectance from the satellite. So if canopy radiant transfer model coupled with the crop model, if crop model simulate LA, those LA will go to the canopy radiant transfer model and canopy radiant transfer model simulate reflectance. Those reflectance matches with the satellite based reflectance, then we can get the yield also. So the approach is like that: remote sensing, NDI or LAI, crop type, climate model with the weather forecast or AWS data you can use for the weather forecast as well as climate data and in-situ observation. Some soil map you require. Right now in India, we are having a NBS LEP, which is authority for soil maps. So it is coarse resolution soil map. But if you are studying okay regional level like okay state or country, that is more than enough. But if you are doing okay district level, you need a more high resolution 1 to 50,000 soil map. So here you see one approach, Oriza model, which is mainly for the rice. Now there is one relationship is developed NDVI against LA. This relationship is forced inside the horizon model source code. So now model is running, estimating that LAI within the model based on the remotely sensed NDVI. Then it is finally estimating it. So that is a, you can say, inversion. Here mainly particularly LAI, horizon model that also simulate LAI. LAI goes to the radiant transfer model and radiant transfer simulate reflectors and finally NDVI. Similarly, satellite also you will get NDVI. The moment you get the best matching between NDVI temporal profile obtained from the satellite data and simulated by the RT model, you can get the that output of that particular pixel of particular model is a if. So it is a, like you can say you have to invert those things. So this is how okay GIS crop model and climate model working for the crop production productivity and assessment mainly okay because all those what we have discussed if you are having the data. But these days, okay, most of the country, mainly tropical countries and developing countries, we are scarce with the weather observation. So if you want to develop forecasting, you very in advance, 30 days advance, 40 days advance. So most reliable approach will be the weather forecast. If we get the good quality weather forecast, high resolution weather forecast from the regional climate model and use within the crop simulation model along with the certain remote sensing based crop coverage, we can get the better for crop production forecast for the early warning of the crop food and the drought. So here you see we have done one for the Punjab, Haryana, where weather forecast at different time step, 7 days in advance, 1 day, 30 days in advance, 45 days in advance, simulated into a reset model to get the forecast. Now you see, weather forecast if we are using, it is improving accuracy. So what I mean to say that it is not only the quality of the forecast is important because in general we get the good quality forecast only for the short range, but for Rabi season where you require mainly temperature, humidity, and wind speed and those kind of observations, which can be anyhow forecasted with a higher accuracy. So that accuracy doesn't matter with respect to the forecast in Rabi season because it is not mainly irrigation is mainly for irrigated agriculture. It is not rainfall based. So here mainly how representative forecast is there because if you are simulating only for one observatory for a whole district, one observatory data and simulating for a whole district yield, then it may goes wrong. But instead of that, if you are having 5 kilometer weather forecast for 45 days, that will be more representative partially about the weather condition of a particular district. So here, what I mean to say, partial perspective power of the weather forecast is much more important compared to the quality of the forecast with respect to the crop forecasting in the Rabi season. So then machine learning algorithm are also being developed with the globally available satellite products as well as globally available satellite vegetation indices. There are so many algorithms are there. People are using random forest, gradient booster, and extreme gradient booster. So many CNN and so many ANN, so many algorithm machine learning algorithms are there. All are trained because all here for machine learning or artificial intelligence, what you require to have better training data set. If you have more like this regional level, if you are having more historical data of 20, 10 or 25 years, so many districts, then you can get better capture the variability. But if you are limited with the data, like field scale, if you are attempting for the field scale yield estimation, then you require to have more number of crop cutting experiment, representative of different variety and this soil condition and climate design. Then only you can achieve better accuracy with the machine learning algorithm. So machine learning that mostly rely on the training. How good training is there, that decides the your final forecasting accuracy. So here, okay, you see, we are not getting okay even with this okay machine learning algorithm training data is there, but accuracy finally, if you go with this most or more of the model, it is around okay absolute 0.8 r square is a 0.8. It is going okay like this, but overall you can say 60 to 80% is there, to forecast accuracy, which can be achieved with the other kind of model also, like phenology based or latitude efficiency. But here, important thing is that you need not to download data. Everything you can do with the Google and edges of cloud computing. All data is available freely. You can just call those data and do online this yield model. So that is all about this. Okay, how? But what challenge is there? We need to have a farm management, mainly the crop yield forecast, to be available at the field scale to help farmer through precision agriculture, and that will be challenge to have a remote sensing, high resolution remote sensing, unmanned aerial vehicle based okay remote sensing, ground and based soil and moisture monitoring, ground based sensor, robotic agriculture, and so on. So that is will be the future for the better yield forecasting at the field level to support precision agriculture. Thank you all.